Hi guys, in this video we're going to be talking about one of the very fundamental objects or data structures used in R called a vector, and we're going to go through a couple different types of vectors and create them manually ourselves. Alright, first off, I've opened R and this is what you should be seeing. You'll get this little paragraph, if you will, or snippet of information here, which tells you the version of R that you're using, the platform, and some important information about R, citing R if you are using it for publication, and then some commands here, some functions that may be useful to you. We'll use probably quit at some point. Actually, when you're done with a session, you can either X out up here like you would a normal window, or you can type Q open close parentheses. Anyway, so you'll get this each time. So if you don't want to see this, one thing you could do is Control L. This is on a PC. On a Mac it's going to be probably Command L, but I'm not sure. Control L. It's not terribly important to do this, but from time to time one wants to clear up the screen to have a fresh kind of palette to work on, or a fresh canvas. Okay, so let's do this, and then now let's get into talking about vectors. First off, I should mention that a very important operator is the assignment. So this is how you assign a name to some object. Okay, so this is, I'm not going to hit enter here. I don't want R to interpret this. This is just basically theoretical here. We're going to use this operator quite a bit in this video, and throughout your use in R you'll notice that this is going to be quite extensively used. So instead of writing equals, which would also work, we tend to frown upon this and prefer this, okay, in R, because you'll see in the future that equals will actually assign when you want to perhaps condition on something. Okay, much more on that to come in the future, possibly. For now, just accept this is a better convention than this for assigning a name to some object. Today we're going to be focusing on creating vectors, a particular type of object called a vector, which is probably arguably the most fundamental and useful. Okay, so let's get into that. So by the way, I could backspace delete all this, or I could just hit the down arrow and that will also delete it all. From time to time I'm going to interject a lot of kind of useful kind of tricks and skills that are might be helpful to you, that might slightly seem off topic, but they should help you in your developing your R skills. Okay, so let's first create a numeric vector, a very basic vector with numbers in it. Okay, and then specifically numbers with decimals. Okay, with the possibility of decimals. So let's maybe do GPA. Let's make some kind of relatable examples. So I want to name this vector GPA. So notice I put the name here. I use the assignment operator here, put a little space between that, and then another space, and then I'll start kind of giving some numbers to this vector. You could think of this as kind of creating a column of made up data. Okay, or maybe I'm reading off some numbers from my score book or whatever. It doesn't necessarily have to be trivial data here. Okay, so another useful function which we're going to use extensively is the combine, or sometimes I've seen it called concatenate function, which is just simply C, open close parentheses, and within these parentheses is where you're going to type in your data. And what this combine function is going to do is it's going to combine everything within these parentheses into a vector. Okay, so within here let's make up 3 or 4 GPAs. So we have, let's say, 3.45, separate them by commas. I prefer to put a space after a comma. It's not necessary. It's just good convention. 3.97. We're just making up GPAs here. 2.98. And let's make a fourth one, comma. How about a pure 4.0, right? So I could type 4.00, but let's see what happens if I just type 4. All right. So I've just created, I haven't hit enter yet, so R hasn't interpreted this yet. I've just created a numeric vector, which is numbers with decimal places, of 4 GPA scores, and I named it GPA using the assignment operator and use the combine function, which is simply C, very simple to remember as function. And within the combine function, I put my data separated by commas. Okay, so now let's hit enter, and you see nothing happens. But if we actually now type GPA, because we've assigned something to GPA, it has been recorded into R's memory, okay, into the environment, if you will. Okay, and there you see the 4.0 actually got the decimals, even though we didn't put them, because it saw that are smart enough to see that this is a numeric vector with 2 decimal places of precision, so it kind of interpolates that. Okay, so GPA is our first kind of vector that we've created. We could check that this is a numeric vector 2 ways, using the str function, which stands for structure. We can check what's the structure of GPA. And if we hit enter, we see in fact it's a number or numeric, and there's 1 to 4 because there's 4 observations. So it's a vector with length 4. It's a numeric vector with length 4, and here are the position of the elements. So here's element 1 all the way up to element 4. Okay, so I can access any one of these elements using these square brackets. So for example, if I want the first element, I put GPA. I want the first element of GPA, I get 3.45. If I want the third, you should at this point guess 2.98. How about if I want the second? And so on. How about if I want a range of them? For example, I want 1 to 3. I want the first 3 GPAs. Okay, I want the first 3 elements in the GPA vector. And so I would get 3.45, 397, and 2.98. Okay, so this is a little bit how to kind of extract data from a vector, so creating a vector and then extracting it and learning how the elements work. All right, so let me hit Control L and clear this kind of screen so we can now create a different type of vector. Let's create a character vector, so names. So eventually I want to combine all these into a nice data set. So far it's just, you could think we got one column called GPA, right? So I don't want, I want to attach names to those GPAs eventually. But at this point, I just want to focus one by one on creating the columns. So here we should make 4 names, because eventually we'll attach those to those 4 GPAs. By the way, the order does matter that I put these names in, because the first name here eventually will get attached to the first GPA in my GPA vector. Let me hit down and let's just look at this while we're making names. So I want to call this name, or maybe first name. By the way, when you name things, you should never put spaces. So this would get you an error message. And there's a few characters that you can't use, but you probably won't run into those. And if you do, just try to name something as kind of short and sweet, but to the point and able to interpret as possible. So first name, so I use underscore, right? I use the assignment operator. I use the combine function. Now within the combine function, I want to put 4 names to combine into this new vector that I'm making. This vector is going to be a character vector. Okay? So names need to be in quotations. So I need to put quotes, and within the quotes I could start putting some names. So how about Alice, comma, Alex. Notice the quotes. Let's get some different letters in here. Maria, and how about John? Let's keep it as simple as possible. Okay, notice all the names are in quotations. The order that I put them in will be the order that they appear. Okay, I hit enter. Now I could look at this vector by typing in the name first name, and you see I get the vector of character of first names that I just wrote in. Okay, now let's look at the structure of this vector. Okay, so the structure function, we used this before. This is going to be a very useful function to see what the structure of our data is, of our vectors, and so on. So this is quite useful. Notice I got within the quotes I put the object that I want to know the structure. Hit enter, and we see that this is a character vector that has 4 elements with indexes 1 to 4. Naturally, this is, you can read this 2, okay, and here they are, these 4 guys right here. So knowing this, I can access a particular name, so I can look at the second name. So I would expect to get what? Alex, right? Exactly. I can get the 4th name, John, right? And so on. I can get the 2nd and 3rd name. Okay? So that's a little bit about extracting. I'll do a video on more on extracting information from vectors and data sets once we have more objects under our belt. Okay? So we created a character vector now. We have a numeric vector and a character vector, and we created them quite independently, but in our minds we have this idea that eventually maybe we'll combine these. Okay. Next, let's make a slightly different type of vector. Let's make a perhaps logical vector. So something like true, false. Okay, so let's say this person's in my course, and this was their GPA, and this was their name, and I want to know whether they passed my course or not. I'm looking back perhaps on old data, okay, and I'm just inputting it. So pass perhaps is a good name. I'm going to assign the name pass to a vector that basically just says true or false whether that person passed. Okay, and I put this in caps. Okay, so R nodes to interpret true and falses as special kind of characters. All right, so it doesn't treat them like names. And notice I don't have to put quotes here. I'm not putting quotes. So let's say the first person passed, second person failed, hence the false. Third person passed, and let's be nice. Let's not scare anyone here. So only 1 out of these 4 failed. Okay, let's hit enter, and let's look at pass. Okay, so nothing out of the ordinary at this point. You would expect this. And let's look at the structure of pass now. So we should expect something slightly different, and in fact we do get a logical vector with 4 elements. Here's the indexes 1 to 4. So here's pass 1, pass 2, pass 3, pass 4, right? And we can index on this. So let's get the 2nd to 4th result. So you see I get fail, false, true, true. So for us, fail pass, right? Because it's an either or thing. It's very binary. So we use this as an excuse to show an example of a logical vector. Okay, these will use a little less than the first two that I mentioned. Okay, now in addition to numeric vectors, you can also have integer vectors. An integer vector is very similar to a numeric vector, except that there's no decimal places. That's the definition of an integer, right? They're whole numbers like 1, 2, 3, 4, 5, 6, and also can be negative numbers, but no decimal places. So we won't take time to kind of go through that. You would then, if you did something like that, you would then get integer over here, or int for short. Okay? And it behaves very similar to a numeric vector, except you have less precision. You won't have decimal places. Okay, so there are cases where you don't have numbers with decimal places, and so there's no reason to have a numeric vector. You have an integer vector. Okay? But now I want to just focus on one last vector that's extremely important and will be extremely important for further analysis, which is a factor. Sometimes this semantically gets called its own type of object, but it's very, very similar to a vector, so we're going to bring it up here. Okay, so here we want to create a vector, and perhaps a good example might be for a factor vector, which I'm about to show you, would be gender. Okay, gender, as you know, is a categorical variable or nominal variable, and it takes one of two possible kind of responses, either male or female. Okay, so that obviously won't be a number. It obviously won't be an integer. It obviously won't be a character. Well, not obviously. It can be looked at as a character vector, similar to the name that we created, right? But since names can take on many, many, many possibilities, almost infinite possibilities, and something like gender very clearly is either male or female, R gives us a way to treat something like gender differently than we would something like name. And this is for many purposes, but not the least of which is for saving memory and computing time. Okay, so let's create a factor called gender. Okay, so first off, there's a number of ways we can go about this. First, let's call it gender. Let's assign the name gender to this vector that we're about to create. Okay, so we're going to create, we're going to make up four genders, or genders for 4 people. Eventually we're going to combine this, remember. So first we can kind of just create a character vector. This is one way to go about it. So we would type male, and we could do it M if you like, F, Alice, sorry, this is eventually going to be Alice, so Alice is clearly male, Alex arguably male, Maria definitely female. I'm just making this up, but I'm trying to be a little consistent with our names up here, that's all, okay, because eventually I'm going to combine these right now. And John male. Okay, so I've created, at this point you should recognize that this should be what type of vector? Character, because it's not any different at this point than the first name object that we created. And in fact, you'll see we get a character. Okay, but now I want to treat this slightly differently than a character vector for reasons that I explained earlier. Because gender is not like name. It's a little more, it behaves a little differently. It's a very finite number of choices you have for the levels of gender. Whereas name can take on almost infinite different possibilities. So we should treat this, R gives us a way to treat this slightly differently. And so we want to convert this character vector gender that we created, right, to what's called a factor. So we still want to call it gender. So in other words, we want to, this will overwrite this gender. Okay, so we could still call it gender. Okay, and there's a function called factor, okay, which will convert a vector into a factor. In this case, all we need to do is to put in the name of the vector that we created here. So basically, we're feeding this into this function factor. And so it's going to convert this character vector that we created into a factor. Okay? And then we're naming this whole thing that we're doing here gender again. So basically, in essence, it's going to just overwrite the previous thing we called gender. And that's fine because we don't really want that. We want this to overwrite it. Okay? So now furthermore, you can comma within the factor function, you can explicitly define the levels that factor can take. And you can leave this out and it will be fine, but sometimes this gives us a little more explicit control over the levels that our categorical variable can take. Okay, so here we know it's either male or female. So male. So here we're being very clear. Here we're being very clear about the levels that our categorical variable can take. So if it was something like blood type, A, B, and O, we could be very clear about that there's 4 levels that this categorical variable can take. Okay, so let's hit enter and let's first look at it. So you see it looks slightly differently than it did when we had it as a factor. Okay, so remember factor looked like this. It put the quotes around it and it just listed it similar to the numeric vector. But factor lists it like this, and then at the bottom gives you this little extra information, tells you the levels explicitly. Okay, so this is, let's look at the structure of gender now that we've converted it to a factor. You see, in fact, it's not a character vector, it's a factor, and tells us with 2 levels. Here are the 2 levels. We made that clear. Within the factor function, excuse me, we made it clear. So here are the 2 levels, and then you see that it just writes 2, 1, 2, 1. What is this 2, 1? Well, if these are the 2 levels, this is level 1, this is level 2, it no longer needs to repeat M, F, F, M, M, F, and so on over and over. It just simply can refer to the level. So level 2 means this is a female. Level 1 means this is a male. Level 2, again, female. Level 1, male. And now compare this to how we put our data in originally over here. You'll see it's just a mapping from this to these 2 numbers. 2 levels of gender, so 1, 2 is the numbers you'll see. Okay? This is just a special way to treat categorical variables, which we'll need to do when we use algorithms, that classification algorithms especially. Okay, let me do one more example of gender of a factor variable, because this one's slightly more involved. Let's do something like color. Let's just make up some favorite colors. And let me show you the second way that you can create a factor variable. So I want to create a factor of favorite colors, perhaps let's say F color, for these 4 people. So this time I'm gonna, right from the get-go, create this factor instead of first creating a character vector like I did and then converting it to a factor. So here, let's go factor. Okay? And here, let's use the combine function within the factor function, and let's make up some favorite colors for these 4 students. So let's say black, red, let's say we only give them a choice of 5 colors, right? So categorical variable. Of course, color has infinite possibilities if you really think about it. But let's say we gave them a limited number of choices, so it's a clear categorical nominal variable ripe for converting into a factor. And blue. Okay, so here are my 4 favorite colors for these 4 folks. And let's close the parentheses. You see here we could also have said comma levels, and then explicitly using the combine function define the levels that favorite color can take, and that could be more than even the ones that we actually observed. But I also told you that you can a lot of times leave this levels out, so let me do that and so show you both ways. So here we're creating this factor f color. We're assigning this name, in other words, using the assign function, to a factor, and then within the factor parentheses, within the factor function, we use the combine function to define this, what would alone be a character vector, right? What I'm putting a box around alone would have been a character vector, much like first name. But by putting it within the factor function parentheses, it'll create a character vector, convert it to a factor in one step. And so let's hit enter, and let's look at f color. You see that we just get a kind of repeat of the colors that we put in here, and also we get this extra information which we don't get with a character vector, levels. So here are the levels that favorite color can take: black, blue, and red. Now, I want you to pay attention to the levels here. Black, blue, red. Notice alphabetical order, right? So it lists the levels in alphabetical order unless you specifically define the levels, like we did with gender. In gender, I specifically chose levels to be MF, and clearly this is not alphabetical order, right? So by doing this, I kind of told it to put male as the first level, female as the second. So here you see 2 levels, 1, 2, 1 was male. But if I had left this levels out, which would have been fine, and I just closed the parentheses here, I would have got this same thing over here, except levels, you guessed it, would have been F, then M, alphabetical order, and then when we looked at the structure of gender, it would have been F, M, right? So then level 1 would have corresponded to females, level 2 would have corresponded to males, so these numbers here would have been 1, 2, 1, 2. In other words, we would have the same exact information, just coded slightly differently. Okay? So if it's important for you to have the levels in a specific order, you can use the levels argument within the factor function. If it's not important and you're fine with just the alphabetically arranged kind of the levels like we did here with color, black, blue, red, alphabetically ordered, then you don't even need the levels function. Okay? So we didn't put the levels. All right, so let's just quickly look at the structure of levels of F color, and you'll see it's a factor with 3 levels. And you see dot 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 because actually, it wants to fit all this on one line, so sometimes it's not going to list all of them. But you'll see that, and then it gives us 1 3 3 2. So 1 is black, 2 is blue, 3 was red. Okay, it just doesn't write it here because it's trying to keep things kind of succinct. But we had it here too. 1 2 3. Right? Now let's see, what is 1 2 3? This is black, blue, black, blue, blue. Sorry. 1 is black, 2 is blue, and these two guys were red. Right? So let's look back at our original data that we created: black, red, red, blue. Okay? So it just gets coded this way. All right? So we looked at numeric vectors. I mentioned integer vectors as a slight variation of a numeric vector. We looked at a character vector. We looked at a logical vector. And we looked at a factor. Okay? Which is a slight play off a character vector. All right, so vectors are the very fundamental building blocks or building objects, data structures that we're going to use in R for data analysis. In the next video, I'm going to combine some of these vectors that we created into a data frame, a data set, if you like, which will be kind of like what we're going to be looking at when we start applying data analysis tools. All right, so till next time, have a great day.